Imagine this. You're strapped tightly inside a spacecraft the size of a city bus, hurtling at tens of thousands of miles per hour across the cold blackness of space. No return ticket, no second chances, just you, and the solar system's deadliest environments, one after the other. Your mission? Not to colonize, not to explore, but to find out what it would be like to die on every planet. It begins with Mercury, a world so close to the sun, it's like standing in a furnace lit by 1,000 suns. Yet strangely, when night falls, if you can call it night, the heat disappears almost instantly, leaving behind a darkness so cold it could shatter metal. Mercury doesn't kill you with mercy, it kills you with contrast. One side will roast your bones, the other will freeze your blood into glass. This isn't fiction. This is your solar neighborhood, and every single world in it is hostile to human life in ways that are so brutal, they defy imagination, until we take you there. By the end of this journey, you'll know exactly what would happen to you if you tried to stand on every planet in our solar system without protection. No suit, no shield, just raw human vulnerability against the violent face of alien worlds. And we won't stop at Mercury. We'll walk through Venus's crushing atmosphere, where the air is acid and the pressure is enough to flatten a submarine. We'll set foot on Mars, deceptively familiar, but silently lethal. Then drift past gas giants so vast, so powerful, that they don't even have a surface to land on. Instead, they'd pull you into storms that have raged for centuries, storms that tear through metal like tissue paper. We'll fall into Saturn, we'll tumble into Uranus, we'll freeze beneath the blue death of Neptune. And finally, far out where the sun is just a pale star, we'll step onto the icy worlds beyond. Every single stop is a new way to die, and every single planet holds secrets that tell us more, not just about space, but about Earth and ourselves. But before we take that first step, let's ask the question that's probably already whispering in your mind. Why even talk about death? Why explore it? Why make a video about how we die on every planet in the solar system? The answer is simple. Understanding how life ends in space teaches us what it takes for life to survive. It forces us to ask, what's so unique about Earth that it's the only place we've ever found where we can breathe, eat, drink, and stand under an open sky? By facing the extreme conditions that would destroy us elsewhere, we come to appreciate just how finely tuned, how rare, and how fragile our existence really is. We also reveal the raw truths of planetary science, the unseen forces that sculpt worlds, the invisible dangers lurking beneath their clouds and crusts, and the raw violence of nature at its most unfiltered. And we'll do all of it without science fiction. Everything you're about to hear comes directly from verified, authoritative sources: NASA, ESA, peer-reviewed journals, and direct data from missions like Voyager, Cassini, Galileo, Juno, Messenger, and the Mars rovers. No exaggeration, no fluff, just real science, made simple and made cinematic. So buckle in, this is the journey of a lifetime, if you could survive it. A glimpse of the journey ahead. Let's preview what awaits. Mercury, no atmosphere, no mercy. Temperatures swing over 1,000 degrees Fahrenheit between day and night. Your body will literally cook on one side and freeze solid on the other. Venus, the hottest planet in the solar system. Not even spacecraft last long here. You'll be crushed, dissolved, and incinerated all at once. Earth, the control planet. The only one we survive, the only one we know. Mars looks safe, feels familiar, but wait until the pressure drops and your blood starts to boil, without heat. Jupiter, the king of planets, a gas giant with no solid surface. Try to stand here and you'll fall, forever. Saturn, elegant rings, deadly depths, a planet where you disappear into layers of metallic hydrogen before your body is torn apart by pressure. Uranus, cold, tilted, quietly brutal, the side of the solar system no one talks about until you feel it up close. Neptune, home to the fastest winds in the solar system, winds so fast it could slice a spaceship in half. Pluto and beyond, freezing, far and mysterious. Dying here isn't fast, it's slow, silent and lonely. Each death is different, each planet is a lesson. Some deaths are instant, like Venus, no time to scream, just darkness. Others are slow, psychological, like Mars, where you might walk a while, even speak, before realizing the atmosphere is thinner than you thought, and now your lungs are collapsing. Still others don't involve bodies at all. Try falling into Jupiter. The atmosphere turns to liquid, then metallic hydrogen. The pressure turns atoms into plasma. You're no longer a person, you're just data. And yet, in every one of these deaths, there's discovery. What makes Mercury so hot and so cold? Why can't Venus release its heat? Why does Mars have dust devils but no rain? Why do gas giants have magnetic fields that could rip apart electronics? What makes Neptune's storms eternal? We'll answer all of it, through the lens of one terrifying, unfiltered question. If you stepped out of your ship here, how would you die? To make this journey accurate, we're relying on data from NASA's Messenger mission, Mercury, Magellan spacecraft and ESA's Venus Express, Venus, Mars rovers, Curiosity, Perseverance, Spirit, Opportunity, Mars, Juno and Galileo missions, Jupiter, Cassini-Huygens mission, Saturn and Titan, Voyager 2 flybys, Uranus and Neptune, New Horizons, Pluto. These missions didn't just send back pretty pictures, they returned raw atmospheric pressures, chemical compositions, wind speeds, surface temperatures and gravitational forces, used by scientists to model what it would actually feel like to stand, breathe, fall and die on each world. This isn't guesswork, it's physics. Because to explore space means understanding risk. And space isn't just beautiful, it's unforgiving. Every planet reminds us that we're fragile, and that Earth is miraculous. This video isn't meant to scare you, it's meant to amaze you. We're not imagining these deaths to be morbid. We're using them to tell the story of how planets form, how atmospheres evolve, how temperatures spike, how gravity warps reality, and ultimately, how life needs a razor-thin balance to exist at all. This is more than a story of death, it's the story of life, and how rare it is to find it. So as we step forward onto Mercury, remember, every death tells us something. Every planet is a chapter, and every second of this journey brings you closer to the edge of the known universe. Are you ready? Let's begin. Mercury. The sun is a monster here. You open the hatch and step out. The first thing that hits you isn't just the heat, it's the light. The sun, familiar from Earth, is no longer a warm yellow disk overhead. Here on Mercury it's 3 times larger, and it doesn't just rise into the sky, it dominates it. It's so bright, so intense, it feels like you're standing under a blowtorch the size of a mountain. Shadows are pitch black, sliced sharply into the glowing surface. There's no blue sky, only blackness, no clouds, no wind, just you, the silence, and the sun roaring down on you like a god. Welcome to Mercury, this is how it ends here. Mercury, the solar system's scorched messenger. Mercury is the closest planet to the sun. It orbits just 36 million miles away, less than half the distance of Earth. It's a small world, barely bigger than our moon. But what it lacks in size, it makes up for in brutality. First, the obvious temperature. During the day, surface temperatures soar to 800 degrees Fahrenheit, hot enough to melt lead. That's not theoretical. That's real, measured by NASA's Messenger spacecraft and confirmed by planetary scientists. But it gets weirder, because at night, just after the sun sets, the heat disappears almost immediately. No atmosphere means no insulation. Temperatures plummet to minus 290 degrees Fahrenheit. That's colder than the surface of Pluto. This means Mercury has the most extreme temperature swings of any planet in the solar system. A swing of over 1100 degrees Fahrenheit in less than a day. All because of one simple reason: Mercury doesn't have a real atmosphere. No atmosphere, no protection, no chance. What Mercury has is called an exosphere, a ghostly thin layer of atoms blasted off the surface by solar radiation and micrometeorite impacts. It's not thick enough to carry sound, not thick enough to scatter sunlight into a sky, not thick enough to slow your fall, not thick enough to save you. On Earth, our atmosphere shields us from cosmic radiation, holds in warmth, gives us oxygen, and slows incoming objects from space. On Mercury, none of that. There's no air to breathe, no ozone layer to block ultraviolet light, No pressure to keep your bodily fluids in a liquid state. So the moment you step outside your ship without protection, your death begins immediately. Let's say you step onto Mercury without a spacesuit. The first thing that happens is, you don't breathe. There's no air, not a trace. You gasp, and get nothing. The clock starts ticking. Within 10 seconds you lose consciousness. That's not an estimate, it's based on real human physiology. The lack of oxygen causes hypoxia, your brain starves, your vision narrows, and within seconds, you're unconscious. But that's just the beginning. Because Mercury's pressure is essentially a vacuum, just like space, the liquids in your body, saliva, blood, fluid in your eyes, begin to boil. Not because they're hot, but because there's no pressure to hold them in liquid form. This is called ebullism, and it's horrifying. Your skin swells, your blood fizzes with gas bubbles, your tongue blisters, your body inflates. Not enough to pop, but enough to rupture capillaries. Your organs are still functioning for a moment, but they're being poisoned by bubbles in the bloodstream and lack of oxygen. Death arrives in less than 2 minutes. Your final seconds are likely silent. You can't scream, your lungs don't work, you fall to the hot ground but you don't burn yet because your blood flow has already shut down. And then just as your consciousness flickers out, you begin to cook. The sun's radiation here is 7 times stronger than on Earth. Not only are you being broiled by visible light, you're being bombarded by ultraviolet rays strong enough to shatter DNA. Skin begins to char, cells begin to mutate, but you're already gone. Let's say you do wear a spacesuit. Modern EVA suits, like NASA's Extravehicular Mobility Unit, EMU, are designed for Earth orbit. They're tough, resistant to micrometeorites and temperature swings. But Mercury is different. Here the sun is so intense that even the most advanced cooling systems can't keep up. Thermal radiation overwhelms you. The heat builds inside your suit and your body can't sweat it out. At first you start to feel dizzy. Your heart rate increases. Sweat pools inside your helmet, unable to evaporate. Your core temperature climbs. And then you hit hyperthermia. Your body shuts down. You lose coordination, then consciousness. In less than 15 minutes, even with a suit, your brain begins to overheat. And then, coma. Death by heat stroke. That's assuming your suit didn't crack from the heat, or from the brutal cold on the night side if you walked too far. Because Mercury rotates slowly, taking 59 Earth days to complete one spin, the sun stays fixed in the sky for weeks at a time. The ground is roasted, and as you cross into shadow, the thermal shock might be enough to rupture suit seams and electronics. Here's the part that breaks your brain. Mercury has water ice. Yes, the closest planet to the sun, with daytime temperatures hot enough to melt zinc, hides frozen water in deep, permanently shadowed craters near its poles. NASA's Messenger spacecraft confirmed it in 2012 using neutron spectrometry and thermal modeling. The craters are so deep and the sun so low on the horizon at the poles that the bottom of these craters never sees sunlight. Temperatures in those shadowed pits remain below -300 degrees Fahrenheit, cold enough to trap and preserve water ice delivered by ancient comets or outgassed from the planet itself. But don't get your hopes up. This ice is completely inaccessible. The craters are steep, remote, and utterly inhospitable. You wouldn't survive the trek to get there, let alone extract the water. Mercury's ice is a paradox. A ghost of habitability, on a planet that can incinerate you in seconds. Let's not forget the invisible killer solar radiation. On Earth, our magnetic field and thick atmosphere protect us from most solar flares and cosmic rays. But Mercury? It has a weak magnetic field, only about 1% as strong as Earth's, and no atmosphere to speak of. That means if the sun unleashes a solar flare, a burst of high-energy particles, you'll be hit directly. These particles damage DNA, destroy cells, and can cause fatal radiation sickness. Mercury is bombarded daily with solar radiation levels that would exceed human exposure limits within minutes. There's nowhere to hide. Mercury has no wind, no weather, no atmosphere. When you die here, it's silent. Your body might slump onto the dusty regolith-covered surface, similar in texture to the moon. The ground is gray, riddled with impact craters, and as sharp as volcanic glass. No one hears you fall. There's no echo, no air to carry sound. In fact, if your helmet microphone was still working, it would only record the sound of your own breath, until even that goes silent. Odd question, but interesting? No, not in the way we think. Without bacteria, air, or insects, your body wouldn't rot. It would just dry out. The heat would mummify you, or if you died on the night side, it would freeze solid. You'd become a statue, a relic, a frozen, scorched human monument to the dangers of planetary exploration. Unless hit by a micrometeorite, common here, you'd remain perfectly preserved for millions of years. No atmosphere means no air, instant suffocation. Ebulism is the boiling of bodily fluids in a vacuum. Radiation leads to DNA destruction and cancer. Extreme heat causes hyperthermia or suit failure. Extreme cold results in freezing to death. Solar flares bring direct radiation exposure. You thought Mercury was bad? It's just the warm-up act. A scorched rock in perpetual agony. But up next is Venus. The true Inferno. The planet that doesn't just heat you, it crushes you. Where acid rains from the sky and the atmosphere is dense enough to liquefy your lungs. If Mercury is the oven, Venus is the pressure cooker. Get ready. Imagine descending into a sky thick with poison. You're enveloped by an endless veil of ochre clouds. Visibility is nearly zero. The clouds are not mist or water vapor, but a dense shroud of sulfuric acid droplets. They burn your eyes even through reinforced glass. As your craft pierces the final layers, the descent becomes a battle against a planet that wants you gone. There is no welcome mat here, only the brutal, crushing grip of a hell world. Below you, a yellow-orange landscape simmers like the surface of a foundry. A lead pipe would melt here in minutes. This is Venus, bright and beautiful from afar, but a searing death trap up close. Venus, often dubbed Earth's sister planet due to its similar size and rocky composition, is the most misleadingly named planet in the solar system. Though it glows brightly in our night sky, what lies beneath that brilliant sheen is a nightmare world sculpted by runaway greenhouse effects, crushing pressures and acidic fury. Venus's atmosphere is 96% carbon dioxide, and the rest is mostly nitrogen with trace amounts of deadly gases, including sulfur dioxide. Its cloud deck, thick and impenetrable to the human eye, is composed largely of sulfuric acid droplets that would burn any organic material on contact. Unlike Earth's cozy 1-atmosphere pressure at sea level, Venus exerts about 92 times that, roughly equivalent to the pressure you'd experience 1,000 meters or 3,280 feet below the surface of Earth's ocean. Surface temperatures on Venus are uniformly around 460 degrees Celsius, or 860 degrees Fahrenheit, hotter than the surface of Mercury despite being farther from the sun. This constant oven-like heat isn't just the result of solar energy, but stems from a runaway greenhouse effect. Sunlight penetrates the clouds, heats the surface, and the thick CO2 blanket prevents that heat from escaping. There are no seasons, no real day-night temperature swings. Venus is simply always burning. Despite the thick cloud cover, visibility on the ground is shockingly poor. The sun's rays are scattered and diffused, giving Venus a dim, yellowish, twilight-like glow, even during daytime. Winds in the upper atmosphere whip around the planet at hurricane speeds, up to 224 miles per hour, or 360 kilometers per hour. But near the surface, the air is still and suffocatingly hot. In this bizarre world, rain forms in the high clouds, but never reaches the ground. It evaporates in the oppressive heat before it can fall far. This is a place where water can't survive, metal melts, and even the idea of life struggles to exist. Death factors. So, what happens if you, a fragile human designed for Earth's temperate ecosystems, attempt to set foot on Venus? Let's start with the most immediate killer pressure. At 92 times Earth's surface pressure, stepping onto Venus's surface is akin to diving to a depth of 1 kilometer in the ocean without a submersible. Your body, lacking the structural fortitude to resist such an immense external force, would be crushed instantly. Your lungs would collapse, your ribcage would implode. Any gas spaces in your body, lungs, sinuses, digestive tract, would be violently compressed. The very oxygen in your bloodstream would be squeezed out, leaving you gasping for air that isn't there. But let's say somehow you're in a suit that holds pressure. Now you face the heat. The Venusian surface is so hot it could melt lead. No known human spacesuit in existence today can handle 460 degrees Celsius or 860 degrees Fahrenheit for more than a few minutes. Most suits designed for the vacuum of space or Mars environments would fail catastrophically. Plastic components would melt, metal fastenings would soften, seals would fail. Even the most cutting-edge thermal regulation systems would be overwhelmed. Corrosive atmosphere adds another layer of doom. Venus's air is loaded with sulfuric acid and other noxious chemicals that corrode metals, plastics, and any unprotected electronics. This acid isn't in tiny concentrations, it's persistent and highly reactive. Soviet Venera landers, among the only machines ever to touch down on Venus, only lasted between 23 minutes and 2 hours before being fried, crushed, or dissolved by the hostile environment. Their lenses fogged, their electronics failed, and eventually they simply stopped talking. Now imagine you, unprotected, you breathe in, the air is carbon dioxide, devoid of oxygen, you suffocate, in seconds. You sweat, except you can't. Your sweat evaporates into superheated acid mist, your skin begins to blister and burn, your blood vessels rupture from pressure, your flesh begins to cook from both outside and within. This isn't like dying on Earth, this is dying in a crucible. Even with a hypothetical advanced Venus suit, one designed far beyond our current engineering limits, your survival would still be measured in minutes, if not seconds. The moment the suit develops even a hairline crack, game over. You wouldn't have time to scream, you'd be dead before the sound left your throat. Let's imagine you open your craft's hatch and step onto the Venusian ground with nothing more than the clothes on your back. You'd be unconscious in seconds and dead shortly after. First, the atmosphere rushes in. Your lungs collapse under pressure, then acid air scorches your airway linings. Your eyes would boil, your skin would ignite in blistering lesions. All of this, and you haven't even taken a step. Before your heart can pump more than a few futile beats, your internal organs would implode and cook. In a standard spacesuit? Now let's give you a suit. Say, a modern EVA suit like the ones used on the International Space Station. At best, the electronics short-circuit within seconds. The cooling system can't handle the temperature. The suit begins to warp and melt. Plastic layers give way. Once the outer insulation fails, your body heats up rapidly, your internal temperature spikes, and you pass out from heat stroke before the suit rips open. Death follows within moments. Inside a specially designed lander, you're now inside a state-of-the-art lander, thicker than the Venera probes, fully pressurized, insulated with advanced ceramics and cooling systems. It might last longer, perhaps an hour, maybe 2. But eventually Venus wins. Thermal expansion stresses the hull, microfractures form, electronics malfunction, air conditioners fail. Once internal temperatures spike past survivable thresholds, death becomes inevitable. Whether it's carbon dioxide poisoning, heat stroke, or mechanical failure leading to exposure, the end comes quickly. Here's a mind-bender. Despite the nightmarish conditions on the ground, some scientists believe that 50 kilometers above Venus's surface lies a habitable zone. At this altitude, temperatures hover around 30 degrees Celsius, or 86 degrees Fahrenheit, and pressure is close to that on Earth. In this strange layer, researchers have proposed the possibility of microbial life, or even floating habitats for future exploration. But descend below this layer, and hope vanishes. Another fascinating paradox: Venus is brighter than any planet in our sky. Its thick clouds reflect nearly 70% of the sunlight, but on the surface it's so dim and orange-tinted that it feels like twilight at best. You see nothing but haze and blurry rocks. The brightest planet in the sky is nearly blind at ground level. Venus rotates so slowly that a day lasts longer than its year. One Venusian day equals 243 Earth days. That means if you somehow survive the descent, you'd have nearly 8 months of sunlight before the dark, even if you could somehow last a single second. Escaping Venus's crushing grip, you float up through layers of acid and pressure, finally piercing the yellow gloom into the blackness of space. You've survived, for now. Your next stop isn't a hellhole, it's home, Earth. But even here, nature can be merciless. What would death on our own planet feel like in space-like extremes? Stay with us. We're only just beginning the deadliest journey through the solar system. Earth. You finally step onto Earth's soil-breathable air, moderate warmth and gravity that feels familiar. It's the oasis of the solar system, for now. The moment your boots touch down on the ground of Earth, it doesn't feel like anything remarkable at first. There's no deadly pressure spike, no choking clouds of sulfuric acid, no furnace-hot winds or ice-blasting gales, just a slight breeze. It's a breeze you can actually feel, because for the first time since this journey began, you're not buried in protective gear. You take a breath, and you live. That alone makes Earth the most miraculous world in the solar system. This planet isn't trying to kill you. In fact, it's been fighting to keep you alive for billions of years. Earth's atmosphere is a mixture of 78% nitrogen, 21% oxygen, and 1% other gases like argon, carbon dioxide, and water vapor. At sea level, the atmospheric pressure is 1 atmosphere, or 101.3 kilopascals, which is just right for our lungs. Not too heavy to crush, not too light to suffocate. The oxygen level is just enough to fuel our metabolism without becoming toxic. A perfect balance created by billions of years of biological activity, especially photosynthesis. Temperature averages around 15 degrees Celsius, or 59 degrees Fahrenheit, thanks to Earth's distance from the Sun and the way its atmosphere traps just enough heat. Earth sits comfortably in the habitable zone, the narrow band around a star where water can exist as a liquid, the essential medium for life as we know it. But that's not all. Earth's magnetic field, generated by the churning liquid iron in its outer core, acts like an invisible shield, deflecting harmful solar wind and cosmic rays. Without it, the sun would strip our atmosphere over time and fry our DNA with radiation. This planet is a finely tuned system, atmosphere, temperature, magnetic protection, all working in harmony to allow complex life to not just exist, but thrive. So does that mean Earth is a perfect paradise? Not exactly. What makes Earth livable also makes it unpredictable. Unlike the static, frozen death of Pluto or the relentless furnace of Venus, Earth's danger is dynamic. It's not always trying to kill you, but it can choose to. Think of hurricanes. Earth's weather system, powered by solar heat, can whip up storms strong enough to flatten entire cities. Tornadoes form in violent updrafts, spinning with winds over 200 miles per hour. Lightning bolts strike with a temperature 5 times hotter than the surface of the sun. And then, there are natural disasters. Earthquakes from shifting tectonic plates, tsunamis triggered by underwater landslides or quakes, wildfires that consume forests, droughts that wither crops, floods that submerge entire towns. These aren't rare freak events, they are part of Earth's natural cycle. Still, the key point remains: Earth gives you a chance. You can prepare, you can shelter, you can survive. Other planets offer no such mercy. Let's say you climb to the summit of Mount Everest, 8,848 meters above sea level. The air there contains only a third of the oxygen available at sea level. Your blood oxygen levels plummet. You struggle to breathe, risking hypoxia. Stay too long without acclimatization or supplemental oxygen, and your brain starts to shut down. Death by altitude isn't instant, but it's inevitable if you're unprepared. Now flip it. Descend deep into the ocean trenches. The Mariana Trench, for instance, reaches nearly 11,000 meters deep. Down there, pressure is more than 1,000 times what it is at the surface. Without the most robust submersible design, you'd be crushed in an instant. The crushing force is equivalent to the weight of 50 jumbo jets resting on your body. So, yes, Earth can still kill you. But it does so in pockets, in extremes, not as a constant state. That's what separates it from every other planet on your journey. From a cosmic perspective, Earth is an anomaly. It's the only known planet with liquid water on the surface, an oxygen-rich atmosphere, plate tectonics that recycle minerals and carbon, and a stable climate, at least until recently. Every aspect of Earth's environment has co-evolved with life. We didn't just appear on this planet, we are products of its conditions. Carl Sagan once called Earth the pale blue dot, a tiny speck in the vastness of space, and yet the only place we know of so far that harbors life. Every other world is hostile by default. Now imagine you left Earth's surface, without a suit, just as you are. You step out into space. Within seconds, you would suffer from embolism. a condition where the low pressure causes water in your body, including your blood, to start boiling at body temperature. Your lungs would collapse if you tried to hold your breath, leading to rapid unconsciousness. You'd suffocate within 15 seconds. The vacuum of space is merciless, and it doesn't care where you came from. So, while Earth sustains us, it also reminds us how fragile that life-supporting environment is. Step just a few dozen kilometers above and it's all gone. Space doesn't need to be far away. It's right above your head. No other planet we've discovered, in this solar system or beyond, has the perfect combination of traits Earth does. Mars may have once had water, but lost its atmosphere. Venus is a cautionary tale of runaway greenhouse effects. Jupiter and Saturn are gas giants with no solid surface. The moons of Saturn and Jupiter might harbor subsurface oceans, but they're locked in ice and bathed in radiation. We've scanned thousands of exoplanets. Some are Earth-like in size or distance from their star. But that's only part of the equation. Life as complex as ours likely needs more. A magnetic field, plate tectonics, a stabilizing moon, a dynamic carbon cycle, and the right balance of greenhouse gases. Earth is more than lucky, it's rare, maybe even unique. The most ironic twist is this. On Earth we don't usually die from the planet itself. We die from accidents, disease, violence, or from altering the environment in ways that make it hostile. Climate change, for example, threatens to tip the scales. By burning fossil fuels, we're changing the composition of Earth's atmosphere, trapping more heat, melting glaciers, raising sea levels, and intensifying storms and droughts. It's as if we're terraforming our own world, in reverse. Nuclear weapons, pandemics, artificial intelligence run amok. The threats we face here aren't natural. They are human. It's a grim irony that the one planet designed to keep us alive might someday be made uninhabitable, not by cosmic collisions or solar flares, but by us. Here's a perspective shift. On every other planet in this series, death is immediate. There's no hesitation, no chance to adapt. You're either cooked, crushed, frozen, or vaporized. On Earth, you can live a full life. Decades of memory, love, discovery. You can learn, create, dream. That's what this planet gives you, not just survival, but potential. This is why astronauts orbiting Earth often describe a profound shift in consciousness, the overview effect. Seeing the planet as a delicate blue marble suspended in the blackness of space makes them realize how lucky we are, and how fragile this all is. So here you are, breathing, safe, standing on the only planet that wants you to live. But comfort breeds complacency. And beyond Earth, the universe resets to default hostility. Up next, Mars, a world that looks like it might welcome you, red deserts, Earth-like landscapes. But don't be fooled, Mars is colder than Antarctica, drier than any desert, and its air will suffocate you before you ever get to appreciate the view. But on Mars, things go bad fast. Imagine standing on a world so familiar in color and texture yet so foreign it could kill you in seconds. You step onto the rust-red soil of Mars under a faded salmon sky. Olympus Mons, the largest volcano in the solar system, looms far to the west like a sleeping giant. Valles Marineris, a canyon system so vast it would span the entire United States, yawns open behind you. The landscape is silent, winds whispering around you at supersonic speed. It looks survivable, until the planet shows its true nature. Let's explore what it's really like to die on Mars, and you know, how little stands between you and a gruesome fate. Mars, the fourth planet from the Sun, orbits at an average distance of 228 million kilometers from Earth. With a radius of 3,390 kilometers, it's just over half the size of our homeworld, making it the second smallest planet in the solar system after Mercury. Nicknamed the Red Planet, its distinctive color comes from iron oxide, rust, that coats much of the surface. But for all its Earth-like qualities, valleys, polar ice caps, seasons, and even evidence of ancient rivers, Mars is an alien world with brutal conditions. Mars has no breathable air. Its atmosphere is 95.3% carbon dioxide, 2.6% nitrogen, 1.9% argon, and a trace of oxygen, less than 0.15%. Compare that to Earth, where oxygen makes up 21% of the atmosphere. The air pressure on Mars is a mere 0.6% of Earth's, averaging just 6.3 millibars. In practical terms, it's like standing on a mountaintop 5 times higher than Mount Everest, and then removing your helmet. Death comes quickly. What happens to the human body on Mars? Let's say you're standing on the surface of Mars, fully exposed, no suit, no helmet, no protection. What happens? First 5 seconds. You take a breath, but there's no oxygen. The carbon dioxide rushes in, doing nothing for your lungs. You feel a crushing tightness in your chest, but not because the air is thick. It's too thin. There's almost no pressure. The boiling point of water drops dramatically at this pressure, so your saliva begins to boil on your tongue. Your tears vaporize. Your skin begins to swell. Your blood starts to bubble. Literally. This is ebulism, the same deadly phenomenon you'd experience in space. By 10 seconds, you lose consciousness due to hypoxia, lack of oxygen. The brain, starving for air, begins to shut down. There's no pain now, but your cells are still dying rapidly. Without pressure, nitrogen dissolved in your bloodstream forms bubbles, like opening a shaken can of soda, and your circulatory system destabilizes. By 1 minute, irreversible damage is done. The body is beginning to freeze. Mars is cold, even during the day. And at night, temperatures can plunge below minus 150 degrees Celsius, minus 238 degrees Fahrenheit. You die of suffocation, decompression, and freezing all within a minute or two. This isn't the dramatic explosion of Hollywood space deaths. It's silent, clinical, and agonizingly fast. Okay, let's say you're smarter this time. You're wearing a state-of-the-art Martian EVA suit. It provides oxygen, pressure, and some protection against radiation. You step onto the surface and everything seems fine, but the danger isn't over. Problem 1. Atmospheric pressure. Even the best suits struggle to maintain internal pressure on Mars because a pinhole leak in the suit would rapidly depressurize it, causing the same ebulism death we just described. You'd have less than 60 seconds to fix it. Problem 2. Temperature swings. During the day, temperatures can reach a mild 20 degrees Celsius, especially near the equator during summer. But these highs are rare. At night, temperatures drop rapidly. Without constant thermal regulation, you'd freeze solid in less than an hour. A failed heater in your suit would be a death sentence. Problem 3. Radiation. Mars has no global magnetic field. It lost it billions of years ago. That means solar and cosmic radiation reaches the surface unimpeded. Over time, this radiation could give you cancer, destroy your DNA, or cause neurological disorders. A Martian day might be fine, but a Martian year would be deadly without shielding. Problem 4. Dust. Martian dust is toxic. It contains perchlorates, salts that, when inhaled, disrupt thyroid function and damage lungs. The dust also clings to everything and can interfere with suit joints, seals, and electronics. It's like the worst beach sand you've ever experienced, but chemically aggressive. Your life on Mars is a ticking clock. Every second your oxygen, heat, and pressure systems are running is a second you're alive. A power failure, a cracked faceplate, a bad solar flare, that's all it takes to kill you. Mars has some of the most dramatic weather in the solar system, but not in the way you might expect. Mars experiences planet-wide dust storms that can last for weeks or even months. Winds can reach up to 60 miles per hour, but because of the thin air, the force is much weaker than on Earth. However, the dust is so fine, more like smoke than sand, that it gets into everything. These storms can block out sunlight for weeks, reducing solar power and plunging habitats into darkness. NASA's Opportunity rover was killed by such a storm in 2018, its solar panels choked off from the sun. Now imagine being a human in that same situation, reliant on solar power for heat and oxygen. You freeze, or suffocate. The biggest weather threat might be the simplest: cold. With no atmosphere to trap heat, warmth from the sun disappears rapidly after sunset. The drop can be more than 100 degrees Celsius or 180 degrees Fahrenheit in just a few hours. Without constant heating, you're as good as gone. Even if you built a base, sealed it tightly and regulated your environment, Mars still wants you dead. Radiation exposure. According to the Mars Science Laboratory and Curiosity rover data, Martian surface radiation is about 233 microsieverts per day, more than 200 times higher than Earth's surface. For astronauts, this exceeds the annual career limit within just a few months. Shielding helps, but deep buried habitats or magnetic protection would be needed. Psychological isolation. Living on Mars would be profoundly isolating. No trees, no oceans, no sky you're familiar with. Days are 24.6 hours long, just slightly off Earth's rhythm. Over time, the psychological toll could manifest as depression, cognitive decline, or delusions. For many, this death of the mind might come before death of the body. Supplies and repairs. Mars has no hardware store. A failed water recycling system, no spare part. A cracked dome, hope you brought extra sealant. Every mission is a bet that nothing will go wrong, because there's no rescue coming. No human has yet stepped foot on Mars, but robotic missions have given us an unfiltered look. The Mars rovers, Spirit and Opportunity, both showed us vast plains, rocky hills, and evidence of ancient water, but both died to the environment, dust storms, and extreme temperatures. Curiosity and Perseverance are still going strong, but they rely on nuclear power, not solar, because the environment is so unpredictable. InSight, the seismology lander, was decommissioned in 2022 after being overwhelmed by dust buildup on its panels. Schiaparelli, from the European Space Agency in 2016, crashed due to a sensor error during descent, overwhelmed by Mars's thin air and fast approach speeds. Even billion-dollar hardware fails on Mars. Humans would be far more fragile. Mars is beautiful, haunting, red, desolate, but it's no home. With every breath engineered, every calorie imported, and every heartbeat at risk, it offers survival, but not safety. Every moment on Mars is survival theater. And yet, people still dream of living there. But dream carefully, because if you think Mars was deadly, the next world has no surface at all. It's the giant Jupiter, a swirling hurricane of storms, radiation, and gravity so intense it could crush you before you even fall. Jupiter. You hover just above Jupiter's swirling cloud tops, gazing down into a storm unlike any other, the Great Red Spot, a colossal hurricane larger than Earth itself, churning relentlessly for over 300 years. The colors swirl in bands of browns, reds, and whites, wild and chaotic yet mesmerizing. But as you peer deeper, a sobering truth settles in. Jupiter has no solid surface. Beneath those endless clouds lies crushing pressure and blistering heat, a hellscape designed to obliterate anything daring to enter. Jupiter is the solar system's behemoth, the largest planet by far, with a diameter over 11 times that of Earth and a mass more than 300 times greater. It's a gas giant primarily composed of hydrogen, about 90%, and helium, around 10%, with trace amounts of methane, ammonia, water vapor, and other compounds swirling in its atmosphere. At the level where the atmospheric pressure equals Earth's sea level, about 1 bar, temperatures plummet to a bone-chilling minus 108 degrees Celsius, or minus 162 degrees Fahrenheit. Here you'd be frozen solid if you could stand. But there's nowhere stable to stand on Jupiter. No solid crust or landmass. Instead, the planet's atmosphere thickens deeper down, with pressure soaring to over 1,000 bars. That's more than 1,000 times Earth's atmospheric pressure at sea level. Temperatures simultaneously rise to thousands of degrees Celsius. Jupiter's fierce jet streams roar at speeds reaching about 540 kilometers per hour or 335 miles per hour, whipping the gases into violent bands that encircle the planet. The Great Red Spot itself is a giant anticyclonic storm twice the size of Earth, with winds swirling at hundreds of kilometers per hour lasting for centuries and counting. Before you even get close to Jupiter's clouds, the planet's deadly radiation environment starts its assault. Jupiter's magnetic field is staggeringly powerful, about 16 to 54 times stronger than Earth's, forming a vast magnetic bubble that traps intense clouds of charged particles. Electrons, protons, and heavier ions accelerated to near-light speeds. This radiation belt is like an enormous, high-energy particle cannon, showering anything within reach with lethal doses. Spacecraft like Galileo and Juno have survived only by shielding and careful trajectory planning. For an unshielded human or probe, the radiation dose near Jupiter's cloud tops would be fatal within hours, inducing severe radiation sickness and cellular damage. Beneath this invisible storm lies one of the harshest environments in the solar system. The lethal cocktail of intense radiation, crushing pressures, and extreme temperatures makes it clear. Jupiter isn't just hostile, it's a cosmic furnace and pressure cooker rolled into one. Suppose you defy physics and plunge from your hovering spacecraft into Jupiter's depths. The first challenge is the violent atmosphere itself. Jet stream winds would batter you at hundreds of kilometers per hour, tearing at any exposed surface. The cloud layers are thick with ammonia crystals and hydrogen compounds, a swirling maelstrom with no solid footing. As you descend, the pressure skyrockets. At a depth of just 100 kilometers below the cloud tops, pressure reaches around 100 bars, already enough to crush a human instantly. Deeper still, pressures exceed 1,000 bars. Over 1,000 times Earth's atmospheric pressure at sea level. This is like being submerged under 10 kilometers of ocean water, squeezed so tightly your body would compress and collapse like a crushed soda can. Simultaneously, temperatures surge. Near the core, estimates suggest temperatures of up to 24,000 degrees Celsius, hotter than the surface of the sun. These blistering temperatures would vaporize any known material and incinerate a human body before the crushing pressure finished the job. Hovering near the clouds without heavy radiation shielding, the kind currently only found in spacecraft like Juno, you'd suffer severe radiation poisoning in a matter of hours. Skin burns, radiation sickness, and eventual death would be unavoidable. The magnetic field that protects Earth becomes a lethal trap here. Descending into the atmosphere, the violent winds alone would batter and shred any attempt at entry. If you somehow survived that, the crushing pressure would flatten you instantly. As pressure and temperature rise, your body would be compressed and cooked simultaneously, a horrific, unstoppable end. Jupiter's Great Red Spot is one of the solar system's longest observed storms, with continuous observations dating back over 300 years. The storm is shrinking slowly but remains a raging vortex larger than Earth. Jupiter's intense radiation belts don't just affect the planet itself, its moons experience a brutal dose too. Europa, Io, and Ganymede orbit within this deadly environment, experiencing radiation far beyond anything on Earth. Europa's icy crust is constantly bombarded, a factor critical to considering its potential habitability. Jupiter's magnetic field creates a mini Van Allen belt system for the entire Jovian system, a reminder that surviving here requires far more than just holding your breath. Surviving Jupiter is not a matter of if, but impossible. You can never land. There is no ground, only deeper layers of crushing gas, fire, and radiation. It's a storm-racked giant that swallows everything. But the journey continues. Next, we move to Saturn, another massive gas giant, but this time adorned with dazzling rings visible across the solar system. Saturn's beauty masks its own deadly secrets. You glide into Saturn's breathtaking rings, a shimmering celestial ballet of billions of icy particles, glinting like diamonds in the sun. The rings stretch endlessly, delicate yet immense, hinting at the planet's mysterious beauty below. As you prepare to skim the upper cloud tops, the scale of this gas giant becomes clear. Saturn is a world both fragile and ferocious, cloaked in swirling storms and invisible dangers. Beneath this dazzling facade lies an environment just as hostile and lethal as its bigger sibling Jupiter, a place where crushing pressure, bone-chilling cold, and fierce winds rule with deadly authority. Saturn is primarily composed of hydrogen, about 96%, and helium, around 3%, similar to Jupiter, but with a smaller core and lower density. It's the second largest planet in the solar system, with a diameter nearly 9.5 times that of Earth. At the familiar 1 bar pressure level, comparable to Earth's sea level pressure, the temperature plunges to a frigid -139 degrees Celsius, or -218 degrees Fahrenheit, which is colder than Jupiter's upper atmosphere. Saturn's atmosphere is marked by colossal storms and jet streams with winds reaching a staggering 500 meters per second, which is about 1,800 kilometers per hour, or 1,100 miles per hour. These winds sculpt the planet's distinctive weather patterns, including the famous hexagonal jet stream circling its north pole, a perfectly six-sided shape so precise and stable that scientists still debate its cause. Below the visible cloud tops, pressure increases dramatically. Just like Jupiter, pressure deep inside Saturn exceeds 1,000 bars, more than 1,000 times Earth's atmospheric pressure at sea level. This immense pressure transforms gases into exotic liquids and metals. The crushing forces here can flatten and collapse any human or spacecraft unfortunate enough to descend. Survival on Saturn is impossible for any known life form or human technology without extreme protection. At the upper atmosphere, the frigid temperature would freeze any unprotected body rapidly. Unlike Mercury's blistering heat or Venus's suffocating acid clouds, Saturn's upper layers are a deep freeze. But freezing is only the beginning. Should you somehow sink deeper, the increasing pressure would compress atmospheric gases into dense liquids. At around 1,000 bars, hydrogen transitions into a liquid metallic form, a bizarre, super-dense state found nowhere on Earth. This pressure would crush any spacesuit or hull into oblivion. Saturn's magnetic field, though less intense than Jupiter's, still poses a severe threat. Measuring approximately 578 times stronger than Earth's magnetic field, it traps charged particles that bombard anything orbiting or near the planet with harsh radiation, enough to degrade electronics and damage living tissue within hours. Unsuited? If you stepped out without a suit, the freezing cold would rapidly rob your body heat, leading to hypothermia in seconds. The thin upper atmosphere lacks oxygen, so suffocation is immediate, but before long, pressure from the deepening atmosphere would start to crush you. Eventually you'd be flattened under pressures that liquefy gases and distort atoms. Suited. Even the most advanced spacesuit or lander technology would fail. The suit's materials would become brittle in the cold and rupture under the crushing pressure. Any life support systems would be overwhelmed by the intense radiation and extreme conditions. The hull of a lander would deform and melt within minutes at deeper levels, just like the doomed probes sent to Saturn's atmosphere. Saturn's famous rings, though dazzling to look at, offer no refuge. They're a hazardous field of fast-moving ice and rock fragments, capable of shredding spacecraft or spacesuits instantly. One of Saturn's most enduring mysteries is its hexagonal storm at the North Pole. Unlike any other planetary weather system known, this six-sided jet stream holds a near-perfect geometric shape, stable over decades of observation. Scientists speculate it arises from complex atmospheric wave patterns, but no definitive explanation yet exists. Saturn's rings themselves are a marvel, composed mostly of water ice, some particles as small as dust grains, others as large as houses. They may be remnants of shattered moons or comets, constantly evolving over millions of years. Saturn's moons, especially Titan and Enceladus, show incredible diversity and potential for habitability. contrasting sharply with their harsh parent planet. Titan's thick nitrogen atmosphere and Enceladus's water geysers have become prime targets in the search for life beyond Earth. From the icy haze and towering storms of Saturn, we set course for the solar system's mysterious ice giants. Next, we visit Uranus, a planet that spins on its side, wrapped in a cold blue-green cloak and hiding deadly secrets beneath. The journey is far from over and the dangers grow even more strange and deadly. Prepare yourself as we continue deeper into the outer solar system. Uranus. A strange turquoise orb drifts silently through space, spinning slowly on its side, a world unlike any other. On Uranus, the sun would rise from the west, reversing everything you thought you knew about day and night. But there's little time to marvel. The bitter cold bites at your skin like a cosmic freeze. The atmosphere here is an alien brew of hydrogen, helium, and methane, the last giving Uranus its eerie blue-green glow. Beneath the calm, cold clouds, danger lurks in brutal winds and crushing pressures. Surviving on this distant world is a test of endurance beyond any earthbound imagination. Uranus is composed primarily of hydrogen and helium, with a few percent methane mixed in. That methane absorbs red light, lending the planet its striking turquoise color, a stark contrast to the yellows and browns of the gas giants closer to the sun. At the 1 bar atmospheric pressure level, roughly Earth's sea level pressure, temperatures plummet to a staggering -197 degrees Celsius, making Uranus one of the coldest places in the solar system. The atmosphere roars with fierce winds, reaching speeds up to 900 kilometers per hour. These supersonic blasts carve out giant storms and swirling clouds, despite the planet's frigid nature. Beneath the visible clouds, the pressure again rises dramatically, surpassing 1,000 bars, crushing and transforming gases into exotic, super-dense fluids. One of Uranus's most bizarre features is its extreme axial tilt, about 98 degrees, meaning it essentially rolls on its side as it orbits the sun. This tilt causes decades-long seasons where one pole basks in continuous sunlight, while the other plunges into decades of darkness. Surviving on Uranus is a challenge dominated by bone-chilling cold and brutal pressure. The atmosphere contains no oxygen, mostly hydrogen and helium, so asphyxiation is immediate for any unprotected human. Temperatures at the cloud tops would freeze exposed skin almost instantly. Even the toughest heat shields or insulated suits would struggle to maintain warmth against -197 degrees Celsius, colder than liquid nitrogen. Without life support, hypothermia would set in within seconds. If you somehow penetrated deeper, where the crushing pressure exceeds 1,000 bars, the forces would deform and flatten any material. Unlike Jupiter or Saturn, radiation is less of a threat here due to Uranus's relatively weak magnetic field, though it's uniquely tilted by 58 degrees. Still, the intense cold combined with pressure leaves no chance of survival. Unsuited, without protection you'd suffocate and freeze almost instantly. The lack of oxygen would rob you of consciousness within seconds. The frigid atmosphere would cause frostbite and freeze your lungs. You'd rapidly lose body heat, succumbing to hypothermia in moments. Suited, even the most advanced spacesuit would be overwhelmed. Maintaining heat against near -200 degrees Celsius temperatures requires enormous energy and insulation. Any breach or failure means swift freezing. The extreme pressure below the clouds would crush you or your craft. There's no safe landing, no shelter, just a relentless frozen void. Uranus's axial tilt means its poles experience dramatic and prolonged seasons, with decades of unending day followed by decades of night, a cycle unlike anything on Earth. This tilt also distorts its magnetic field, tilting it 58 degrees off-axis and offset from the planet's center, producing complex magnetospheric interactions. Despite its cold and distance, Uranus still hosts faint rings, less bright and less dense than Saturn's, and storms that, while less violent than Jupiter's, still rage fiercely beneath the haze. Leaving the sideways giant behind, we set course for the last stop on this perilous journey, Neptune. the blue ice giant where winds howl faster than on any other world, and the cold bites even deeper. Brace yourself. On Neptune, the fury of the solar system's outer planets reaches its terrifying climax. Neptune, the blue tempest of the outer solar system. Imagine the blackness of deep space suddenly giving way to a vast sphere painted in stunning hues of cobalt and azure, swirling with tempestuous storms far beyond Earth's wildest hurricanes. This is Neptune, the eighth and farthest recognized planet in our solar system, a world of extremes and mystery, where the very atmosphere howls with supersonic winds, and the cold can freeze you in seconds. Your spacecraft plunges into Neptune's upper atmosphere, and immediately you are battered by relentless storms whipping at more than 2,000 kilometers per hour. The air is not air as you know it, but a complex blend of gases that would instantly suffocate and freeze you. Thunder roars invisibly, and lightning flashes far below through dense methane clouds, illuminating an alien sky awash with the blue glow of methane ice crystals. This is the wildest weather you will encounter on any planet in the solar system. A giant blue tempest, unpredictable and unforgiving. Environment: a world cloaked in blue ice and fierce winds. Neptune's atmosphere is predominantly hydrogen, about 80%, and helium around 19%, with methane making up the rest. A key player that absorbs red light and reflects blue, giving Neptune its mesmerizing cerulean color. At the pressure equivalent to Earth's sea level, 1 bar, temperatures hover near an almost unimaginable -201 degrees Celsius, or -330 degrees Fahrenheit, making Neptune one of the coldest places you could visit. This frigid temperature freezes most known gases into ices and crystals, creating clouds composed of methane ice and ammonia hydrates. Beneath the upper cloud deck, pressure and temperature skyrocket. As you descend, the atmosphere thickens exponentially, reaching pressures thousands of times that of Earth. The crushing weight of these layers squeezes gases into exotic fluid states, while heat generated from the planet's interior pushes temperatures upward again, creating a hostile environment that vaporizes anything that dares venture too deep. Adding to the hostility is Neptune's magnetic field, about 27 times stronger than Earth's, tilted and offset in peculiar ways. This field traps and accelerates charged particles, exposing the upper atmosphere to intense radiation, which would fry any unprotected electronics or living tissue in a matter of hours. Death factors: the triple threat: cold, crushing pressure, and lethal winds. Here, survival is impossible, even in theory. 1. The cold. The sub-zero temperatures of -201 degrees Celsius are beyond what any known organism could endure without immediate cryogenic injury. Any exposed tissue would freeze almost instantaneously, causing cellular destruction and fatal hypothermia within moments. Even the most advanced heating systems on a spacesuit would struggle to counteract this relentless thermal loss. 2. The pressure descending into Neptune's atmosphere means confronting pressures that would crush a human body flat as a pancake. The atmosphere's density grows rapidly. The weight of overlying gas layers increases pressure to thousands of bars. These pressures are so immense that gases behave like liquids, and materials not engineered to withstand such forces would be compressed, shattered, or vaporized. 3. The winds: Neptune holds the record for the fastest winds in the solar system, clocking over 2,000 kilometers per hour. Supersonic speeds that can tear apart spacecraft or suits, causing structural failure. These winds whip storms like the Great Dark Spot, an Earth-sized tempest of swirling clouds, lightning, and ammonia ice. The violent shear forces from such storms can shred any explorer's gear within seconds. Together, these forces create a lethal environment. Unprotected, a human would perish in seconds, freezing, suffocating in the hydrogen-helium atmosphere, crushed by pressure and battered by storms. Fate scenarios: a journey into the impossible. If unsuited, without a pressure suit, breathable atmosphere, or thermal protection, a human would suffer immediate embolism, the boiling of bodily fluids caused by low pressure, along with hypoxia from the absence of oxygen. Hypothermia would set in within seconds, followed by death from crushing pressure if you somehow survived initial exposure. If suited, even the most advanced hypothetical suit faces impossible challenges here. The intense cold alone demands heat input far beyond current technology. The violent winds would damage or rip apart protective layers. The crushing pressure would require a rigid, heavy exoskeleton that would be too cumbersome for movement. Radiation shielding would add weight and complexity. Survival times might be measured in minutes at best, with any failure leading to catastrophic death. Onboard a probe robotic missions like Voyager 2, which flew past Neptune in 1989, survive only briefly as they traverse the outer atmosphere. No spacecraft has ever attempted entry or landing. All would be crushed, melted, or lost in the crushing depths. Twists and scientific fascinations. Neptune's storms rival Jupiter's famed Great Red Spot in power and scale. The Great Dark Spot observed by Voyager 2 was an immense storm system the size of Earth itself, churning with violent winds and turbulent clouds. Since then, new storms have appeared and vanished, revealing the dynamic and chaotic nature of Neptune's atmosphere. The planet's deep blue color is a direct result of methane's absorption of red light, but scientists still puzzle over subtle color variations caused by unknown atmospheric chemicals or cloud layers. Neptune's tilted magnetic field and complex internal structure make it a fascinating laboratory for understanding planetary magnetism and fluid dynamics in ice giants, worlds very different from our gas giants Jupiter and Saturn. Closing transition. From fire to ice, only Earth holds life. From the furnace of Mercury to the frozen chaos of Neptune, our journey through the solar system's planets reveals a brutal truth. Earth's delicate balance of atmosphere, temperature, and magnetic shielding is incredibly rare and precious. Neptune's storms remind us of nature's raw power, majestic yet merciless. No matter how advanced our technology becomes, surviving on these distant hostile worlds remains a challenge of cosmic proportions. As we leave Neptune behind, a shining blue gem, we carry back the lesson in the vast deadly reaches of space. Earth remains our singular refuge, a rare cradle for life in a universe of extremes. As our journey through the solar system draws to a close, one truth stands clear. Earth is unique, our singular oasis of life, protection, and comfort in a vast cosmos of hostility. From breathable air and moderate temperatures to a magnetic shield that deflects deadly radiation, Earth offers exactly what we need to survive. Every other world we've visited is a hostile realm, shaped by extremes that challenge life at every turn. Yet these brutal environments are not just warnings, they're also invitations. They remind us why exploration matters. By studying the fierce storms of Neptune, the crushing pressures of the gas giants, or the barren cold of Mars, we gain invaluable knowledge about planetary science, survival, and the limits of life itself. As we venture further beyond our solar system to distant exoplanets and icy dwarf worlds like Pluto, we continue to expand the boundaries of human curiosity and our understanding of what it means to be alive in the universe. So, whether you're gazing up at the night sky or dreaming of the stars, remember, our fragile blue planet is worth cherishing, protecting, and exploring. And it may just be the key to unlocking the mysteries of the cosmos. What other unimaginable worlds await us beyond the edge of our solar system? Join us next time as we explore the frozen frontiers of Pluto and the mysteries of worlds even stranger still. Thanks for joining this incredible journey through the deadliest places in our solar system. It's a stark reminder of just how precious and fragile our home planet really is. If you enjoyed traveling from the scorching surface of Mercury to the fierce storms of Neptune, be sure to hit that like button and subscribe so you don't miss our next adventure, diving into the frozen mysteries of Pluto and beyond. Have questions or thoughts about these deadly worlds? Drop them in the comments. I love hearing what you think. Until next time, keep looking up, stay curious, and remember, the universe is full of wonders waiting to be explored. Stay safe out there, Earthlings.